All right. One of my favorite, you're always going to hear me say my favorite topics, but this lesson is going to be about a system of linear equation in three variables. So I did a previous video on a system of linear equation in two variables. Now we're just going to add one more. So we had x and y. Now we're going to add z. So in this particular lesson, we're going to, hold on, I want to change this to my pointer. I think this is it. Yeah. So we're going to do the larger system of linear equations, which is just mean we're going to do them in three variables. I'm going to show you systematically how to figure out what the solutions are, because the more variables you add, it's really good to have a system to work through it. And then we'll talk about some common mistakes, and then as always, some key takeaways. Okay, so let's get into it. So systematically solving larger systems of linear equations mathematically by hand. So you always got your hands, okay? So the elimination method is best used, and you're going to see when we walk through the steps, you want to do the elimination method. We'll still be using elementary operations, and then of course another good thing is technology. In this particular lesson, we're not going to do matrices. I'll do a separate video on how to use matrices. That's probably one of the best methods I've found when you have more than two variables. And then, of course, you can always use a calculator to kind of check your work. But I'm assuming that most of y'all need to see the steps so that you know what's involved. So the methods, using the elimination method for solving, first thing you want to do is the first equation needs to have a coefficient of 1. Then you want to eliminate the x term from the second equation. Then you want to eliminate the x term from the third equation. Then you kind of start over. Now you want your y term to have a coefficient of 1. Eliminate the y term from the third equation. And then by then you should be able to back substitute. So that's how it's going to work. So your first equation is going to have x, y, z. Your second equation is just going to have y and z, and then your third equation should end up having z. That's what these steps are going to take us through. So let's work through each step so you can see how it works. Let's see. Let me see if I talk about something else? Yeah. Okay. So what I want you to see before I switch over to my iPad is, so right now this is equation 1, equation 2, equation 3. Whatever elementary operations that you're doing, whatever equations at the top will always be equation 1, whatever's in the middle will always be equation 2, and whatever's on the bottom will always be equation 3. Doesn't matter what operations you're doing. If you didn't watch my my other video on solving system of linear equation in two variables, watch that one and you'll see what I'm talking about labeling the equations. So let me switch so I can show my iPad. Okay. Okay, cool beans. So first, what we need to do is step 1 says that we need the first equation needs to have a coefficient of 1 in the term. So we're saying that this first equation here, these are coefficients. The numbers that are in front of the variables or the terms, those are the coefficients, okay? So this right here, that would be an understood 1, that would be a 1, that would be a 1, that would be a 1, and that would be a 1. Okay, those are the coefficients. So when they say the first equation needs to have a coefficient of 1 on the x term, that means on this x term, I needed to have a coefficient of 1. Well, if you notice, this equation has a coefficient of 1 on the x term. So what we're going to do first, and I'm going to put, I'll put what we do in, how about we'll put what we do in blue? Will that work? I'm going to interchange row 1 and row 2. So, matter of fact, hold on. I'm calling these equations. So I want to stick with the nomenclature. So I'm going to interchange equation 1 and equation 2. Okay? Equation 1 and equation 2. Basically what that means is I'm going to take this equation and I'm going to rewrite, paste, right? and we're going to switch equation 1 and equation 2. So I'm going to take equation, move this right here, right? And then move that equation up there. And then I'm going to move this equation back here. Boom. So when you write it, basically what you're going to do is you're going to rearrange equation 1 and equation 2. When you do that, see, I just moved equation 1. So now notice that this equation here is now my equation 1. Okay, then this becomes equation 2, and that becomes equation 3. Okay, that does not change at all. Whatever's the top, middle, and then bottom. Okay, cool beans. So now step 2 says we're going to eliminate the x term from the second equation. So we're going to eliminate this term from the second equation. Remember, our goal is to have, you're going to have x, y, z, then you're going to have y, z, and then you're going to have z. That's what we're working towards. So now the next step is to get rid of the x term in the second equation. So how can we do that? Well, I want to make this 0, right? So that goes back to doing our row operations. Well, if I multiply this by -2 and I add it to this +2, that would make it 0, right? So let's do that. So I'm going to take -2 times equation 1, and I'm going to add it to equation 2 to get my new equation 2. That's how I write that. I try to write it out verbatim so that I remember what it is that I'm doing. So I'm going to take -2 times equation 1. I'm going to add it to equation 2, and I'm going to get my new equation 2. Again, if you haven't watched the last video on solving linear equations in 2 variables, definitely go back and watch it, and this will make more sense. So here we go. I'll do this part in green where you see my work. So I'm going to take -2 times equation 1, and I'm going to add it to equation 2, and I'm going to get my new equation 2. Now, when you're working these out, don't feel like you have to, don't feel like you have to write out what you see me writing out here. I just want to make sure that you see what's going on in my head. But if it helps you to do that, I would highly recommend doing it. That way you can kind of see how it works. So if I take -2 times equation 1, so I'm looking at this equation here, I'm going to get, I'm going to get -2x, right? Minus 6y minus 4z equals -2. Okay, I took -2 times everything in this equation. And when you're doing equations, whatever you do to this side of the equation, you also have to do to that side of the equation. That keeps the equation balanced, okay? So we have to remember that. So I took -2 times every term in the first equation, and now we're going to add it to equation 2. You know what, let me do. I'm going to write it like this. Sorry, I'm trying to think what color to do because I want it to stand out that we're, I'll use gold. How about that? 2x plus y minus z equals 2. Okay, and we're going to add those together. Now, what do you notice happens? This cancels, right? Which is what we want. We want to get rid of the x term from the second equation. So, cool beans. That cancels. And then you have what? You have a minus 6y plus y. That's going to be a minus 5y. And then minus 4y plus a minus 4z. That's going to be a minus 5z. And -2 plus 2, that gives you 0. So this is my new equation 2. So when I get my, this is what I have. X plus 3y plus 2z equals 1, minus 5y minus 5z equals 0, and then x plus y plus z equals 2. Okay, so far so good. So this is my new, this is my, this is my new equation 2 right there. Okay, my new equation 2. So far so good. Okay, remember at any point during the video you can leave your question. So now let's go to step 3. So I'm going to leave that right here. And now we're going to go to step 3. Now, remember, step 3 says we need to eliminate the term in the third equation. Because remember, our goal is to have x plus y plus z, or whatever, sorry, x plus y plus z, y plus z, and then z. That's our goal. So we're going to keep working down. So now we need to eliminate this from the third equation. Well, let's do the same thing. If we multiply -1 here, right, and then we add it to this equation, this will go away because you'll have a negative x and a positive x. So let's do that. So we're going to take -1 times equation 1, and we're going to add it to equation 3. -1 times, and we're going to get our new, equation 3. Okay? So we're taking -1 times equation 1, and we're adding it to equation 3. And we're going to get our new equation 3. Again, remember, I'm showing you this so I can show you what I'm doing in my head. But this helps me keep in order what I'm doing. Okay, so as I follow the steps, I'm just making sure I'm writing down, because when the equations get so big, it is easy to kind of get lost. So that's what we're doing here. Okay, so -1 times equation 1, that gives me a negative x minus 3y minus 2z equals -1. Because whatever I do to this side of the equation, I also have to do to that side. That's how you keep the equations balanced, okay? So I took -1 times each term. And now I'm going to add that. Get my real pen. Add that to equation 3. Equation 3 is x plus y plus z equals 2. This is going to cancel out, which is what we want. We wanted to eliminate the x term from the third equation, okay? So this cancels out, perfect. We end up with -3 plus y. That's going to be a minus 2y, right? And then a -2 plus 2z, or -2 minus z, excuse me, that's going to be a minus z. And then -2 minus 1, that's going to be a positive 1. So that is my new equation 3. So let's rewrite it. So we have x plus 3y plus 2z equals 1 minus 5y minus 5z equals 0, right? And then a minus 2y minus z equals 1. So far, so good? Minus 2y minus z equals 1. Okay, step 4. Now that we've gotten rid of the x terms, now we need to get rid of what? Well, before we do that, we need to turn this. That was step 4, right? Let me make sure. Yeah, this needs to have a coefficient of 1. And once that has a coefficient of 1, then we need to eliminate it from the third term. So you notice we're just going through each of the terms. So let's do that one. So I need this to be a 1. Don't make it harder than what it needs to be. Don't try to see what you can multiply to the other equations. How do I turn this coefficient into a 1? We'll just divide it by itself. Remember, any number divided by itself is itself. So what I'm going to do, I'm going to take a -1/5. I'm taking a -1/5 because I want it to be a 1. I don't want it to be a -1. I want it to be a positive 1. Times equation 2 to get my new equation 2. Now, I don't have to add it to anything because my goal is just to make it a 1. Okay, so that's why I'm just taking 1/5 times that. So if I take negative 1/5 times equation 2, it's going to look like, let me write it. Let me write it so you can see it because it's fractions. I know a lot of people don't like fractions. It's going to look like this. 5 minus 5y minus 5z. And whatever I do to one side of the equation, I have to do to the other. We know anything times 0 is 0. So when I do the distributive property with this, I get minus 5y over minus 5, right? Because it's a negative and a negative. And then minus 5z over minus 5, right? And then this just becomes 0. If I'm keeping up with what I'm doing, I'll just put 0 over 5. So if you notice, negative 5 divided by negative 5, right? This minus 5 divided by that minus 5, they become 1, and we know that this becomes 0. So now our new, let me just go this way. So now my new equation 2 is y plus z equals 0. Y plus z equals 0. Does that make sense? This negative divided that negative, and so a negative divided by a negative is positive. So that's why it's y plus z. Okay? So this is my new equation 2. Stick with me, stick with me. So let me write it. So now we have x plus 3y plus 2z equals 1. We now have y plus z equals 0. And then we have, minus 2y minus z equals 1. Okay, step 5. Now, because we're getting there, we have the x plus the y plus the z. We have the y plus the z. Now we just need z by itself. So now we need to get rid of this term from the third equation, and then we'll be able to work our way backwards. Okay, so eliminate the y term from the third equation. So we're dealing with this equation here. So let's move this up. What can we do? Well, I need this to go away, correct? So if I can make this a 2, when I add them together, if I make that a 2 and I add them together, they'll be 0, right? So let's take 2 times equation 2, add it to equation 3 to get my new equation 3. You'll notice throughout all of this, I'm always I'm jumping from whatever I do the math and then I add it to get my new. I do the math and then I add it to this to get my new. I do the math. I didn't add it to anything, but that gives me my new. I do the math. I add it to this to get my new. So that's, you notice it's a constant pattern, okay? So let's do that. So I'm taking 2 times equation 2, and I'm going to add it. I did write it like that. And I'm going to add it, to equation 3 to get my new equation 3, okay? So let me do that. 2 times equation 2 right here. Y'all see that? Okay. So that's going to be 2y plus 2z equals 0. My equation 3 is minus 2y minus z equals 1. We're going to add these together. That cancels out, which is what we want, right? We wanted that. And then we end up with 2 minus z. That's just going to be z equals 1. Okay, so we did the 2z minus the 1z and then 0. So z equals 1. So now this is what we have. And now we can back substitute. We can go backwards now. So, right? So this is what we have. And we have z equals 1. So that's how you kind of work through it. And then now you're able to plug this into here, right? And then after you plug that value into there. Okay, so now that's the last step. Let's back substitute so that we can get to the final answer. So if we do back substitution, and this should be pretty straightforward, I'm going to say if z equals 1, then y plus z equals 0, right? Y plus 1 equals 0. Solve for y. You end up with, that cancels. You end up with y equals -1. And then, okay, if z equals 1 and y equals -1, then we're going to take that top equation, x plus 3y plus 2z equals 1, right? So then we have x plus 3 times -1. That's going to be -3. I don't want y'all to be mad at me. Hold on. Let's do it like this, so y'all can see what I'm substituting. So this is -1, and that's 1. Okay, that's what I substituted from here. Okay, so then you end up with x plus -3 plus 2 equals 1. Combine like terms. Whoop. You get x minus 1 equals 1, right? And then add 1 on both sides. When you do that, that cancels out and you get x equals 2. So it looks like we have the solution. Looks like we have x equals 2, y equals -1, and z equals 1. Yep, 2, -1, and 1. Now, this is an independent system because it has one solution, okay? Remember, when you write your ordered pairs, it's x, y, z. This will be I think they call it triple ordered pair. But x first, y second, and then z. So as a triple ordered pair, I need to look that up. I can't remember, but I think that's what they call it. It would look like this. And always check your work. Always check your work. Make sure that it fits. I've checked my work on this, and basically to check your work, what you'll do is go back to the original equations, because you want to make sure that that's what it works for, since that's what you were working with, right? Go back to the original equations, okay? And plug and chug, okay? So you have 2x plus y minus z equals 2. You have x plus 3y plus 2z equals 1. And then you have x plus y plus z equals 2. So I'm going to plug in x, y. Okay, so 2 times 2. 2 times 2 is 4. Plus y is -1. Minus 1 equals 2. 4 plus -2 equals 2. 2 equals 2. Because the 4 minus, okay? Cool beans. Now let's do this one. X is 2. So I have 2 plus 3 times -1 plus 2 times 1. But -1 plus 2 equals 1, right? 1 equals 1. That's good. And then 2, -1, 1 equals 2. 2 minus 1, 1 plus 1 equals 2. 2 equals 2. So it checks. Make sense? Cool beans. All right. Common mistakes with this, like I mentioned before, not following specific steps, getting mixed up on the type of solutions. Watch the previous video on system of linear equations and two variables because I go over the different solutions. Not checking your work. Always check your work. Check your work, check your work, check your work. Whether you graph it, whether you use your calculator, check your work. Make sure it works. Check your work. Okay? Check your work. You should check your work. Key takeaways. Follow the steps. Just go in order. Eliminate the x variable. Eliminate the y variable. You should have x, y, and z left on the first equation, y and z on the second equation, and then the z on the third equation. Don't make it hard. Use the simplest elementary operations that you can. Okay? Simple, 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 simple. And as always, you should be able to complete your assignment with success. Remember, there might be some questions that are easier or harder than others. Follow the steps that we covered in this video. Write down your steps. Write down what you're thinking, because when some of these get pretty involved, write it down so you can remember what you're thinking and you can see it. And then remember, at any point during the videos, you are more than welcome to submit your questions because I am always here to help. All right. Talk to y'all later. Bye.